So I have the code from my previous implementation. I'm just going to modify this to for regressor. Let me look at each method and update it as required. This will stay the same, no changes required. And fit method, these are still valid, and x, y will still stay the same. List and float and class labels won't be necessary. This is a regression problem, no class labels required. And len of x and y and len of x and 0, and this won't be required because there is no class labels anymore. Okay, x and y, len of x 0. I'll put up a few more handling of the errors. K cannot be greater than y. K cannot be larger than training data. Looks good. And this would be super important. The target cannot be string. It should strictly belong to float or int. Invalid data type found in y. All right, that looks about good. Okay, so self dot distance type is this. Self dot k is good. X, and now I'll make the changes here. X is strictly an input or a feature column, and the previous case I had made it to lowercase to imply it is one of the features, not the only feature. That looks good. And the predict method will still say the same, no more changes required. But here's where the changes come from. Computing the distances, check, no changes. Getting sorted distances, check, no issues. Sorting the target values, this is where things change. With respect to the distances, sorted target, yes, this is where things should change. Target values as self dot model of y. This is not required anymore. The computing distances between the new point and x itself. There's no more y, and we'll have to change the distances formula also. So this sorted distances, that looks right, and yes, this looks good. And instead of creating a frequency map, what do? This is not required anymore. We just take the top k labels, top k values, and the predicted output is we are supposed to take the average. So sum of all the values by length not the length is, which is self.k here. Yeah, that looks good. And we return the predicted output. Okay, calculate the distances between x. There's only one feature and one target. In the previous case, each feature had two uh, coordinates, x and y. This looks good. Okay, let's go ahead and look at the compute distances. So this is not required anymore, and this also. The new input will be, this is on a single one dimension point, and we will not need this anymore. So math dot square root of x to minus x1 the whole square for x to I in x. And similarly, these are just absolute values for x to I in x. Looks good. Okay. We just make it as this. Okay, that looks good. And evaluation metrics are going to change. The prediction is going to stay the same. This is also going to stay the same. Let's change the evaluation metrics. I'll just go for eval metrics. I'll just go errors as yt minus yp for yt comma yp and zip of ytest and ypred. And we'll need to square. So you have the errors or mean squared errors. So MSE is that. RMSE would be mat dot square root of MSE. So evaluation metrics, we just go MSE comma RMSE is self dot eval metrics of ytest and ypred, and MSE is MSE and RMSE is RMSE. Okay, that looks about right. Yes, that looks good. All right, looks good. Okay. So we just got we'll just keep x as same and y also as same. You don't need class labels anymore. Okay, and then yeah, you don't need the class label here. I'll just keep it Euclidean and then later test it out for Manhattan. I'll take as 5. New input would be single value 44, looks about right, and x test, let me take it to be 3, 5 and 7, and let this be 4, 5 and 6. Yes, different data samples for x test, training and testing, so there's no data leakage from the code. choose this. There's still class labels, yes. So dot model dot x. So this x is giving me trouble. Dot compute distance missing one. What is that? Yes, this is not necessary anymore. Unsupported. Okay. Am I missing something? Yes. I need sum of errors. Yep, that looks good. So when the input is 44, the predicted output is 5. MSC is 0.34. Let me round this out. That looks about right. Mean squared error is 0.35. Root mean squared error is 0.59. I think that's pretty good. So yes, this was K&N regressor implementation. See you in the next video where I'll be implementing SVM classifier and extend that to regressor also. SVM is going to be intense mathematically. We'll have Lagrange multipliers, convex optimization, etc. See you there.